All right, hello everyone. This week we're going to be going over section 1.8, 2.1, and 2.2. This is our last section from chapter 1 before we move on to chapter 2. So our last section here with chapter 1 is just simplifying expressions. And we have our objectives here. Our objectives, we have 5. Number 1 is simplify expressions. Number 2 is identify terms, numerical coefficients. Number 3 is identify like terms. Number 4 is combine like terms. Number 5 is to simplify expressions from word phrases. So starting with objective 1, simplifying expressions. Currently, we simplify expressions using methods and properties from previous sections. These are all the sections that we've gone through so far, and then especially using the properties from last section. So the properties we use from last section and we learned from last section, we will use them often, but that doesn't necessarily mean that we will explicitly state them each time. We're going to use our properties for what they are without explicitly saying them, so we are just utilizing their attributes as opposed to actually stating a property. So let's go ahead and simplify an expression using the properties and everything that we've learned so far in our chapters, in our sections from chapter 1. So we want to simplify our expression. The expression that we have here is 4 plus 2 times 3k plus 7. So we just need to simplify as much as possible. So we can say that this expression, or here, let's go down a step. The first thing we have to do is we have to simplify whatever is in our parentheses using our order of operations. 3k plus 7 is in its most simplest form, so what we want to do is distribute our 2 into our expression inside of our parentheses. So we'll be using our distributive property. So we're going to have 4 plus, and using our distributive property, this gives us 2 times 3k plus 2 times 7. And we can label here that we used our distributive property. So, all right. So we use our distributive property. Okay, well now let's simplify our expression more. We have 2 terms that are being multiplied, or technically 4 terms, 2 separately being multiplied together. So let's go ahead and do those multiplications first, and then see what we have after that. So multiplying 2 and 3k gives us 6k, and multiplying 2 and 7 gives us plus 14. So we've simplified, and now we see that we have 2 constants, 4 and 14, and 6k. 6 has a variable on it, so it is unlike 4 and 14. But since 4 and 14 are both constants, they are alike. So let's go ahead and rearrange this statement. We can rearrange a statement since each term is positive and we're adding them together. So rearranging them would be our commutative property. So we can rearrange them to say 4 plus 14 plus 6k. And here we use our commutative property. And the step in between, all we really did was simplify. By multiplication, specify. So now that we have our 2 constants being added to each other in order, plus our final term 6k, we can go ahead and add 4 and 14 to get 18 plus 6k. And since we can't combine 18 and 6k, this is our final answer. So all we did was simplify. And our simplified expression is 18 plus 6k. So moving on to objective 2, we want to identify terms and numerical coefficients. So a term is a number or constant, a variable or product or quotient of a number. and one or more variables raised to power. So basically, when we identify terms, this is going to be any kind of chunk or unit of numbers. So some common terms or terms that you may see, something like 9x, 15y squared, -3, -8m squared times n, 2 divided by p, or k. Pretty much anything that is being multiplied together and stated as kind of one unit is what we would call a term. So in the term 9x, the numerical coefficient, or simply the coefficient, we don't have to call it the numerical coefficient every time, we can just call it the coefficient of the variable x is 9. So the coefficient of 9x is 9. Then we have some other examples of coefficients in our chart below. So if we have something like the term 8, then our coefficient is just 8. And if we have something like -7 times y, our numerical coefficient is -7. So really what you're looking here is that if you have a number times a variable, whatever that number is going to be your coefficient, not the variable. So in things like when we see -26 times x to the power of 5 times y times z to the power of 4, it's just going to be that number there in the beginning. It doesn't necessarily have to be at the beginning, but it is pretty much just the constant that is attached to a variable. Or if you only have that constant, it is its own coefficient. So an important thing to look out for. So it's important to be able to distinguish between terms and factors. So in something like 8x cubed plus 12x squared, this expression has two terms. It has two units that you're adding together. And that would be 8x cubed and 12x squared. Terms are separated by a plus or minus symbol. So that's how you know the difference between your terms. Factors in this case would be something like 8x cubed times 12x squared. So this would be a one-term expression, since when you multiply them together, you're going to end up with one term. So these are factors that are being multiplied. So there is a difference there. Moving on to objective 3, we want to identify like terms. So terms with exactly the same variables that have the same exponents on the variables are like terms. This just means that if you have constants, so numbers without variables, those are like terms. Something that has the same variable and the variable has the same exponent. So that means that if you have something like 6t and 4t, those are like terms. They have the same variable and they both have an exponent technically of 1. Similarly, we have 16x squared and -7x squared. I realized I totally forgot to write q. There we go. So -29 times pq and 2 times pq. Same goes for 3x squared times y and 5x squared times y. So what we see here is that our variables have the same types of exponents, so therefore we can say that they're coefficients, or these are like terms. So unlike terms would be any combination of the two. So with 6t and 4v, we have different variables. They both have exponents of 1, but the variables are different, so they're unlike terms. Then we have 16x and -7x squared. In this case, they have different exponents, so they're both x, which is the same variable, but 16x has an exponent of 1, and -7x has an exponent of 2. Then we can have -29 times x times y squared and 2 times xy. So they have the same x variable and exponent, but they have different exponents on the y variable. So that's why they would be unlike terms. And then lastly here we have 3 times wz cubed and 5uz squared. So in this case, we actually have different variables and different exponents. Since we see that w and u are different variables, but then we also see that we have a z cubed and a z squared. So we have different variables and different exponents. So this would also make these unlike terms. So it's going to be useful to identify our like terms and our unlike terms, since in our next objective we are going to be combining our like terms. So recall the distributive property, which just tells us that we can multiply some number to a sum of another, and we can distribute that number we're multiplying. So if we have something like a times b plus c is equal to a times b plus a times c, this can be written in reverse as b times a plus c times a is equal to b plus c times a. So the second form here provides justification for combining like terms. Remember that only like terms can be combined. You cannot combine unlike terms, you can only combine the like terms. So in essence, this is telling us that if we have our like terms, we can go ahead and add the coefficients. So in simplifying an expression has been simplified when the following conditions have been met. So all grouping symbols have been removed, all like terms have been combined, and operations have been performed when possible. So this is just kind of giving us these guidelines for how we know an expression is finally simplified. So let's go ahead and combine our like terms in our expression and simplify the one we have here. So we have 10k minus 7 minus 2 times 3 minus 4k. So we have a much longer expression here. And we're going to begin by doing what's in our parentheses. This is our order of operations, so we want to do this first. Since 3 minus 4k can't be simplified because they are not like terms, then the only thing left we have to do is use our distributive property and distribute our 2. So let's go ahead and do that. So we're 10k minus 7 stays the same. Now we're going to have minus 2 times 3 and a minus 2 times negative 4k. And this was our distributive property. So now since we have multiplication terms, or multiplication factors, we can go ahead and simplify those. Because we want to be able to combine our like terms, but we want them to be simplified first. So we're 10k minus 7 stays the same. But now since we have 2 times 3, it's going to be minus 6. And then we have a minus 2 times negative 4k, which is minus a negative 8k. Which, since we have a double negative, this will turn into plus 8k. So all we did here was simplify with multiplication. So now we want to combine our like terms. And we can rearrange our expression here by using our commutative property. But our commutative property only lets us do it with addition. So let's go ahead and change the subtractions into addition with additive inverse. So our minus 7 will become plus negative 7. So plus negative 7. And our minus 6 will become plus negative 6. So now we can rearrange our terms. And when we do this, we can rearrange them so our like terms are next to each other. So now we can say 10k plus 8k plus negative 7 plus negative 6. And here we used our commutative property. And now we can combine our like terms. We see 10k and 8k are like terms, just like negative 7 and negative 6 are like terms. So let's combine them. So 10k plus 8k is going to be 18k. And negative 7 plus negative 6 is going to be negative 13. And here we combined our like terms. Since 18k and negative 13 are not like terms, and this means that our expression is simplified. And we can simplify it a little bit further by just writing it as 18k minus 13. And here we just simplified. So 18k minus 13 would be our final answer. This would be our simplified expression with using our combining like terms. All right, so lastly, we have objective 5 here we are just simplifying expressions from word phrases. So example 3, we want to write the phrase as a mathematical expression using x as the variable and simplify. We have our phrase here, the sum of 9 and 2 times the sum of a number and 3. So quite a few things going on here. So first things first, we have the sum, so we're dealing with addition, and we're just gonna write the addition symbol for simplicity's sake. So we have the sum of 9. So since we're saying the sum of 9 and something else, this here means that we are adding 9 and this whole expression. So we're adding 9 and this expression. Now we can take a closer look at our other expression. Our other expression is telling us 2 times the sum of a number and 3. We know that a number just means x. And since we have the sum, this means we're adding x and 3. But we also have 2 times this sum. So we want to multiply gonna run out of room here. Multiply the sum by 2. So all right, quite a few things going on here. But let's go ahead and start forming this. So we have the sum of 9 and something else. So we can start our expression by writing 9 plus whatever is left. Then we know that the rest of this expression is going to be 2 times another sum. So we're going to say 9 plus 2 times, and we're going to write our parentheses. And now inside of our parentheses, we have the sum of a number and 3. So this means that we're adding x and 3. So we're going to have 9 plus 2 times x plus 3. So this is our mathematical expression. We have 9 plus 2 times x plus 3. And now we want to start simplifying. And we're going to go on to the next one. Because we want to combine our like terms. Starting with our parentheses, we have x plus 3, but that's in its simplest form. So we're going to focus on multiplying 2. So we're going to use our distributive property. So we'll end up getting 9 plus 2 times x plus 2 times 3. This is distributive property. And now we want to simplify so we can add our like terms. So now we're going to end up getting 9 plus 2 times x, which is 2x, plus 2 times 3, which is 6. So we simplified. And now we see we have 9 and 6, which are constants, so they're like terms. But 2x is an unlike term. So let's rearrange our expression to say 9 plus 6 plus 2x. In this here, we use our commutative property. So now combining our like terms, we can go ahead and add our 9 and 6, which gives us 15 plus 2x. And since 2x of 15 are unlike terms, that is as simplified as we can get. So our final step there was simplify, but then this was our final answer. So there we have it. That was our section on simplifying expressions, so especially using our combining our like terms, which is a really important concept that we're going to be using throughout our next few sections. So all right, section 2.1 is next. So we've finished chapter 1 and on to chapter 2.